right, so part 2, dealing with angle C. Well, it says sine of C. Notice what we've done is we've changed the opposite and adjacent. Now opposite is 3, adjacent is 4. Again, because if we're looking here, that one's opposite. There's your hypotenuse, and 4 is that. So sine, if you look here, is opposite over hypotenuse. So opposite is 3. Hypotenuse is 5. Cosine of C, not surprisingly, would be 4/5. Tangent of C is opposite over adjacent, which is then 3/4. Any questions on angle C in this particular example? Keep in mind this was a right triangle, and which angle did I not ask you about in this particular one? The right angle, which happened to be angle B. In this next one, I am going to ask you about angle B, but luckily, angle B is no longer the right angle. Once again, the one I'm not asking you about is angle C. All right, writing it down again. So I figured the more times you see it, the more times you write it, probably the better. So sine of A, well, if we're talking about angle A, we're sitting right there. So what would you consider 12 in this case? If we're talking about angle A, 12 is which one? Adjacent, I heard it. Yep. 13 is which one? Hypotenuse. 5 then is left over kind of to be opposite. All right, well, sine of A says opposite over hypotenuse, so it is 5/13. Cosine of A is adjacent over hypotenuse, so 12/13. Tangent of A is opposite over adjacent, so 5/12. Any questions how I came up with any of those fractions? Now, this next one I did with angle B, I did it this way twice, or for 2 reasons, I should say. One of them was to see if you could do cosine first, and the other one was to show you something that maybe you did not notice on the previous example. If you do cosine of B, well, this becomes opposite the 12 there, and the adjacent is now the 5. So it's adjacent over hypotenuse if we're doing cosine. So adjacent is 5 over hypotenuse of 13. Sine of B, then, is opposite over hypotenuse, which is tangent of B is not 5/12. It's 12/5 because you do have to still do opposite over hypotenuse. Okay. Once again, realize all those fractions could be written as decimals. Okay? And you're wondering, why does he keep telling us that they could be written as decimals? Because again, that's how your calculator is going to deal with it. Okay? It's going to give you the answer in decimal form. Okay? So earlier I told you to go get a calculator because we were going to do these, and this is actually the last one we're going to do today in class. First thing you might want to notice on the sheet I have over here, it's in RAD mode. That is incorrect. You do not want RAD mode. That is radians. Most of you in here do not know or have not been introduced to radians. Some of you have. In here, we're dealing with degrees. So what you want to do if you have the TI-30X2S, which is what most of you have, I believe, hit the DRG button, and then I believe it gives you 3 options. It gives you DEG, RAD, and GRAD, correct? Make sure DEG is the one that's underlined, and then just hit enter. Once you do that, it should bring DEG up on your main screen. Those of you with the TI-83s, is that anybody in here? You hit mode, and then I think it's the 3rd option down. The TI-83s do default to radians. Okay, did you get it? Okay, what you do is the 3rd option down, it's radians would be the one highlighted, degrees would not be highlighted. Make sure degrees is highlighted, then hit enter is how you would change it to degree mode. The only problem with the TI-83s is it doesn't show you on the main screen what mode it's in, where the TI-30s it does. And simply, now all you got to do is type in sine, and you'll notice it automatically gives you a parenthesis if you have one of those calculators that shows you what you're typing in. And then all you have to do is type in 43, it automatically, it doesn't actually put a degree symbol on there for you, but it is doing it in degrees for you, okay, because that's the mode you've put it in. Now, the hardest part for some people on this particular problem is rounding where you're told, and that's why I chose this particular example to see if you could round where you were told to, which is the nearest 10,000th. So is anybody confident enough in their rounding skills to give me what their calculator, again, rounded to the nearest 10,000th? Jenna? Very good. 0.6820. I believe it was 0.6819, but then it gave you like a 5 or a 6 or something like that afterwards, and so you do have to round it up. Then the 9 rounds that, kind of rounds up that to 20. Now, keep in mind that so far we've just right here been having like an angle A or an angle B or something like that. Now, the calculator actually gave you the angle, so over here is kind of like that fraction we've been getting this whole time. And we're going to learn how to match things up so that we can actually find angles. Okay? So go ahead and try cosine of 84 right now on your own. I think the rounding is a little bit easier on this one. But one of the reasons I chose this one is you might look at the first example and say, hey, that was 43 degrees, and then this is 84 degrees. This answer is going to be bigger. No. It's actually going to be smaller, guaranteed. Okay. Again, I know that because I know where this comes from. If you want to learn that a little bit deeper, that's advanced math. So cosine of 84, point. Is 0.1045. Again, that could be some fraction over there. All right. But right now, we're going to kind of just do the basics and get it so that you can do the more complicated stuff. Okay? And as I've told the classes above, Chapter 8, it's really best if you can be here every day, especially for notes. Okay? Any questions? Again, we're going to leave that last example of what 4 there for some other time. Not today. Do you have any questions? Right. Very good question. Ryan was saying, how do we know if we got the right answer? And right now, I'm going to be very honest with you, Ryan, it's going to be very difficult for you to tell. And that's what we're going to work towards through the rest of this chapter so that you can tell, wait a minute, that's probably not right. Okay? And somebody last hour, once they got partway through their worksheet, asked me a question that I thought was very good. We'll see if you ask the same one. Okay.